10 in the optimization notes. It reads, the manager of an 80-unit apartment complex is trying to decide what rent to charge. Experience has shown that at a rent of $600, all the units will be full. On the average, one additional unit will remain vacant for each $20 increase in rent. Find the rent charge so as to maximize revenue. All right, so read the question to understand it. We're looking at this from the perspective of a apartment complex manager. They're trying to decide on again, how much rent should they charge in order to make the most money. They've got 80 apartments. I think of it as like the now is they're charging a rent of $600 and all of them are full. So if we find how much they're making now, we just multiply 80 times 600, okay, the number of units times how much they're charging per unit, and that gives us how much they're making now. But we're not satisfied with that. We want to see if we can charge more. So it says the plus minus in that is if we increase the rent by $20, then for every $20 increase, one person is going to say, I'm not going to live here anymore, and they're going to lose one apartment and the rent from that. Read the problem. There's not really a picture to label to go with this one. State what we're trying to optimize. We're trying to optimize revenue. So how do we find revenue? Revenue, like we said, is cost per unit times the number of units. All right, so it's a product. So we need to be able to model those two things, cost per unit and the number of units that are renting, in order to find this revenue. So let's do that. So let's break them down one factor at a time. So cost per unit. So it starts off at $600. And that's going to increase, right? So we're talking about $20 increases. So go back to 7th, 8th grade and Math 1, where we're thinking about a linear increase. We've got a initial value, $600, and then we've got a rate. Okay, so take that 600, and then we're adding $20 per unit that we're going to lose. All right, so we didn't even state our variable. We should do that first. Our variable, I think what makes sense in this part is how many units are going to be lost. Okay, so this is a function of how many units are going to be lost. So 60 plus 20x is our cost per unit. Again, that gives us our cost for each unit. So that means the number of units that we're renting, we started off at 80, we're just going to take away X units, all right? However many units we're going to lose, all right? That needs to be subtraction there. Okay, so there's our revenue equation. What else do we do next? Solve a secondary equation. We've already put our you could consider each of those factors to be our secondary equations. We've already put them into our optimization equation. Step 6 is to simplify. All right, so I would multiply this out unless you just want to do product rule. Either way, we should get the same answer. I multiplied mine out and got this quadratic. And then we want to take the derivative, find our critical points. Did we talk about a constraint for x? We didn't. Constraints for x. It can't be more than 80 because we've only got 80 units to lose. If we lose all 80 units, then we're not getting any revenue. So you could consider that as an option, but your revenue is going to be 0. It's not going to be your solution. We do want to consider that you could lose 0 units. All right, so we kind of want to consider that one endpoint. You could call it considering both of them, knowing that the second one is not going to be our solution. Okay, so back to our revenue equation. Let's take the derivative of that. Derivative of a quadratic is a linear, so we should expect just one critical point from this. It's not undefined anywhere since that's a linear function. So where does r prime equal 0? solve that, we should get 25. It's a negative slope on our derivative, so we're going from a positive r primes to negative r primes. That tells us this is a maximum, since we're a sign change from positive to negative. So let's put that value into our table. Let's compare it with our endpoint at 0. If we did not increase the price at all, our revenue would be 48,000. It's not too shabby. But if we increase the price, what would this say? This would be increasing the price by 25 20s. Okay, so if we wanted to know what that value was, which we do, because that's what they ask for. They say, find the rent to charge so as to maximize revenue. So they're looking for the rent to charge. We increased it by 25 times. So we just want to multiply 20 times 25 and add that to 600. All right, we should get 1,100. That's how much we should charge rent in order to maximize our revenue to $60,500.